I think the fact that this is such a unique facility demanded a unique architecture as well. Demanded an architecture that has never been built before. And that is certainly what we accomplished. The aquarium building had a level of complexity that exceeded probably anything that we had done before. Even though we had been involved with complex curved buildings in the past, this one had a constantly changing curvature with a linear pattern superimposed on that, which makes it extremely difficult.
We understood that designing the facade for the aquarium with its geometry and scale is a challenge. It's not only about a design idea, it's always linked to, okay, how is this actually constructed? With the abilities of Ken Pett and Radius Track together with James Catronis, it was possible to retain all these design ideas even with the required changes that needed to be made to the geometry to get this impression of the sort of continuously wrapping of the facade around the aquarium.
The exterior wall of the aquarium is a complex wall system consisting out of multiple layers, with a primary feature being the fact that it is a ventilated wall system, meaning that there's an airflow within the cavity of the wall system, and that any water that penetrates through the exterior layer also has a path to get out of the wall system.
Due to our past collaboration with Radius Track, we approached them to assist us with the development and documentation of the facade system. Radius Track 3D modeled and fabricated the structural framing and detailed the exterior facade system as the requirements exceeded our in-house capabilities. They also designed, and we jointly fabricated the aesthetic and NOA mock-ups. The mock-up process validated the constructability of the assembly and defined the installation logic of the facade system. Due to the specialized nature of the parallelogram geometry, Radius Track recommended Catronis Consulting to lead the surface and pattern development for the exterior skin.
James Catronis' 3D modeling capability enabled us to three-dimensionally look at every possible attachment, every possible intersection with different materials, and be able to tweak this to comply with the as-built conditions.
The construction of this exterior wall is quite amazing. You can take a look at the wall. You see that there's not a hole, it's not a square box, right? There's curves, there's overhangs, and that's not easy to do on an exterior envelope. So it's quite incredible that they were able to accomplish what we see here, and it looks so beautiful.
The ability to build the exterior wall of the aquarium is something that we probably couldn't have done as a company even as little as 10 years ago. The fact that we've got tools such as 3D modeling available to us and the ability to translate that model practically into the field is what makes the difference.
We have borrowed tools from the aerospace industry. Those tools allow us to not only model the geometry, but the complex sets of relationships between building systems. How does the skin relate to the concrete? How does the pattern relate to the skin? And how do the tiles relate to that pattern?
We had a limited number of sessions together where they showed, okay, here we learned this as-built condition. We would change this, and now this giant layout slightly adjusts this. Is this still as you envisaged? And in most cases, they did a fantastic job. We could just nod it off and said, yeah, the design intent is still there.
Through this process, we were able to identify clashes, identify possible engineering problems, highlight them, and keep in mind that we still had to maintain the exterior linear pattern that had a tolerance of 3/16 of an inch. We probably had to build this exterior wall 10, 15, 20 times before we actually got to the job site. So by the time that we got to the job site, we knew exactly what to expect and could deal with it.
For this aquarium building, their biggest concern was that the surface be made exactly and smoothly so it looked perfect, like it came out of a mold. That was their biggest concern, regardless of how it needed to be built. When we first got involved with the aquarium building, there was a design put forth by the engineers for a facade construction method. We looked at it a little bit differently in the effort of trying to eliminate a lot of the structural steel that was there. That was going to be very difficult to attach to, it was going to be difficult to install, would have required a bit of crane time as well, quite a bit of that, and eliminated all the steel structurally that was replaced with cold form steel frame. Once our systems are installed, they're much easier to attach to the building, much easier to attach all the layers to, easier to make adjustments if some are necessary, and overall, a much better package economically and cost effectively.
We developed a process on this project where we were able to take the two-dimensional details, deploy them three-dimensionally, and begin to create a feedback loop where we were able to gain exposure on the project all the way around.
We're building a piano, a Swiss watch out of metal studs. It added a complexity to the project that I've never experienced in 30 years plus in construction. Well, the 3D model contained all of our information for this project. Our shop drawings provided no dimensions, no numerical dimensions for our layout. Everything came from the 3D model. As the studs were being erected, we had our surveyors verify and send data back to our modeler, who then put them back into model to verify exactly where the wall stood. Our as-built studs were as compared to the model.
Physically surveying in every drywall stud on the exterior of this building on multiple locations across the length of the stud. That is the degree of accuracy that this project demanded.
Well, when I first saw the design, to be honest, I was a little worried. How are they going to build this? But the right team came together. They got all of the knowledge together. They did their shop drawings. We built the mock-ups to make sure it could be done. And then when they were out here in the field, it was quite incredible to see just how everything progressed in such a way that it just alleviated everyone's concerns.
From my observation, Ken Pat, working very closely with Radius Track and James Contronis and his team, they took all those various parts and pieces, the building structure, the plaza elevations, the door and window openings that went into it, the aquariums at the top level, and integrated all those into their thinking about how do we approach putting together a skin that will not only be watertight, absolutely watertight with all the different kind of components that come together, but also have the look and the fit and the feel that the design team asked for, and at the same time engineer it to get the Miami-Dade NOA required for the hurricane resistance.
So it was fantastic to see it executed. As an architect, I think you also need to recognize there are so many other hands involved, right, that sometimes also drive the look of your building.
Delivering a project as complicated as the aquarium building is only possible by a collaborative effort. This team was put together because they're the experts in their field and were focused on what needed to be done to create a project that's the best for the owner and the building, and that is the future of architecture.
Ken Pat is very proud of the exterior wall assembly at the aquarium building. This wall embodies the best of what we do through the use of advanced engineering, modeling, fabrication, and construction services in realizing the architect's vision.